Hello and welcome. I'm Shadow of Shadow Gaming, bringing you Programming with Shadow, episode 31. In today's video, we're gonna, as my comment says, pick back up from here. So what we're gonna do is we're going to continue building our registration sim. So this is being recorded right after the other one, so I haven't thought about some of the other to-dos from last time yet. So what we'll do, we'll go ahead and fill out the registration here and fill out the simulation part of this, and we'll get it actually running first. Then we can worry about fixing up some of the edges. So where we stopped off last time, we were starting through setup code, so setting up the simulation. So we did things like we got the actual number of registrations based on a random distribution. We set up the registration windows. We set up these numbers, which suspicious that I added these by accident. Something I possibly added that we don't actually need. Generate arrival. This is where we're going to pick up from, and then start the time and start the counts. So our goal is we're gonna see that we counted that all the events were processed and how long we took to do it, and then at the end we're gonna use that information and say, okay, we need another line, maybe something like that. We need to start here, so we'll say generate arrival events, passing the actual number of registrants. So just based on that, you can already tell that it's going to do something. And we're not. This one might can be static. Let's do this. Right now we're in a local function. Nothing says you can't have a local function within a local function though, so let's try that. I don't necessarily mean I like this format, but I think this will be fine, and I think we won't use this anywhere else, so we'll see. So static void generate arrival events, passing in int number of registrants. All right. Wait a minute. I don't think this does what I'm planning on it to do. Let's go ahead and up here, and we're going to use a something we haven't used before, but I think I think there's something wrong here with all my logic. We'll do private read only priority queue. I don't remember why I used a priority queue though. So see if I can go back through and remember. We'll do it like that, but I don't think this is what I want to do. We'll let it go and see. So that means this can't be static though, because what we're going to do is we're going to add on to this queue. So that I did with the queue, what it's supposed to do is it's the order of people coming into the event, and it's ordered by time. So we're generating the time as we go. What we're about to see is that I don't think it does that. I think I've made a mistake with my generation. We'll see. So we'll start with 4 int count equals 1, count greater than or equal to number of registrants, plus plus. So now we have a time span start equals I did this as another method. We'll do it like that again, but this is getting pretty nested. I may want to break these out. So private span get arrival time here. We'll see. So int so seconds an hour, so that's 60 times 60, so we'll do that. I got the braces, man. Yeah, everything's all. Yeah, all right. Pull this out. Close that. We'll do it like this. There we go. That was the extra. Lesson learned. Let's not use that many of them. We'll do time span get arrival time const int seconds in hour equals 60 times 60. So that's 3600, but we'll say it out like that. And then we'll say int uniform distribution equals distributions dot get uniform, passing in hours operation times seconds an hour. So we'll do it in. So what we're going to do is we're going to get the number of seconds. Let's go ahead and create that. So we'll come over here. Do public static int get uniform. We'll pass in int max value. So int. Now we can just do this. Return RNG dot RNG. It is RNG dot next one max value. So that says go from one up to whatever max value. That maybe it should be max value plus one. Maybe. We'll leave it there, but that should be plus one. Here we need to make it into a time span for return. So we'll say arrival time equals new 0, 0 in seconds. So we're getting it in seconds here. So we'll let the time span object figure out how to convert those to time span. There we go. There's our time span. That gets us a start. So there's this is an arrival. Another variable we need to add. So let's add a variable. So up here we can say what here private read only date time and open time. Might not actually. That may be another holdover from GIMP. Yeah, this may be the only time it actually gets used. And if it is, we'll want to adjust that. But if not, that'll do. Let me do a find here. Let's see. We do use. Okay, it's setting up the default values. Let's actually do that. Up here. We can do it up here in the variable. We don't need that. We can say date. Dot today year. A minute. Yeah, we're going today dot month time dot day dot day. It'll be a long line. So this is hours, so we'll say 8 hours. This should be day, not day. So let's add a constant here for the 8. Normally you don't want magic numbers. Those are just numbers that don't mean a lot. Right there, it's hard to see what 8 there stands for. Let's do public int public constant opening time equals 8. That is more clear. So now we can say opening time. So there we go. There's a little more setup. We can also do a little more here for we can set this here. We already set the registration windows else. Not yet. All right. There's just a little more code. So now we have the generate arrivals. So generate arrivals. Assuming this actually works, what it does is it generates the arrival time, so it gets when they arrive in the range. It creates the event and loads it on the priority queue. The priority queue is based on time. So what we're going to do is say, okay, as we get values out of the priority queue, we'll do them based on time. So that way whoever got in line first comes out first, and that way they arrive to the simulation in the correct time and go into the different lines. That's what we're using that for. If there's a bug there, it's possible. We'll worry about that as we get there. That fills out the setup method. We'll just that comment. It doesn't mean anything. For that one, it doesn't mean anything. So let's begin. So this will be the main portion of the simulation. We'll say while, like that, while priority queue.count is greater than 0. So there, we've set up the priority queue. So now while there's values in the queue, I think that's a decent comment. We're going to leave it. These all end up in here. This one stays on the outside though. All right. So let's see. So what we're going to get off the queues event. So I say person here, but to get event from queue. Then we'll say event current equals priority queue.dequeue. So can return null, right? Okay, I don't think it can return null. If there's nothing there, I guess it fails, which makes sense. So we might want to do a dequeue. We'll leave it there because we are checking the count right before that though. So that may be all we need there. We'll do events process plus. So we're doing another event. So now let's check here. So if current dot event type is event type arrival, we'll do these in two separate methods. Handle arrival else if dot event type is event departure, handle departure. So we'll have some kind of something that happens as they enter and leave the queues. Else here's an error case. So we'll say throw new exception, valid event, and no. So this is a logical problem on our side. Whoever's using this wouldn't be able to get to this problem. So this is error issue. This is a logic problem. Because there should only be 2 events. So we're under the control there. So this shouldn't happen, but we'll log it out in case. We'll do that because we gave it a toString, so we'll be able to see all the information there if there's an error, but there shouldn't be an error because that's a logic problem. So handle arrival and handle departure. So although I'm only gonna use these once, I think they have a chance of being fairly large, so not. put it at this level, I guess. So there's still a local function. Not hardly all the way out. So we'll do count of arrivals plus, so we'll increment the count. Here's where we actually make the registrant. What else? It takes the here. We'll do it like this, more of the new style. Int window index equals get shortest line. We don't have that method yet, so let's add another method. Only place we use it, so we'll just do return. We'll do int get shortest line. So the only time they care about a line is when they arrive, so that's why this is all right. So int index equals 0. Shortest line equals int dot max value for int I equals 0. That's the number of windows. We're just going to loop through the windows. I plus. We'll just grab their count. So if registration windows at I count is less than the shortest line, shortest line equals that count. Rather than access that twice, we can just do it once. Index equals I, and at the end we'll return the index. Yeah, that'll work. So let's do this. Let's say int count equals. We'll do that, and then here. There we go. There's this little shortest line method. Just loop through and find the shortest. Up here, then we can say registrant dot window queue number equals registration windows at index. We call that. It is window index, yeah. Dot count. At window index. Dot queue. Registrant. Registrant numbers at window index. Add registrant.registrant.date. So that I still don't feel like that I actually needed that. I feel like that was an addition I added, then it wasn't actually a good addition. I believe I was going to use it for statistics, but then I don't believe I actually use it for statistics. So again, that might be a candidate for removal. Here's just a method we haven't done yet. There we go. We'll create one more method. This one we use in a couple of spots, so we'll have to move it on up. We'll do private. What? Private void. Get a registrant for service, passing in registrant. Int window index. Yeah, this is going to be a good one. You can already tell because window index isn't actually used in my example. All right, so we'll do time span duration equals get service duration. So there's a method. We have that. It's only used once, so I'm going to say it's a good candidate for putting in here. We'll say time span get service duration. So this is what I'm going to use this for, is to say, okay, this is how long it takes to get through this. So what we're going to do there is we're going to get the negative exponential, or negative exponential duration. So we have how long we expect it to take. We're going to deal with that. So one thing we're going to need is another constant, I believe. Let's come up here and add a constant. We'll say, this is public. Let's make these private. I don't think they're needed outside yet. Minimum service time in seconds. I think we said 90 seconds. No, we said 60. Said 60. Okay, so there we go. We're saying we can't do any better than 60 seconds, so it takes at least 60 seconds to register. There we go. You consider current event. All right, down here. Where did I do? I successfully lost my method here. Go. All right, so double distribution equals say duration here equals minimum service time in seconds minus distributions dot get negative exponential, passing in expected registration duration minus the minimum time in seconds. So get everything on a zero base. Let's go write that method. Again, I don't think this one will be exactly like we did before, but it'll be close. Public static double get negative exponential double. So we'll give it an expected value for starting point as well. This will just return negative expected value times .o minus math.log rng.next double math.b. There's just a different one. What we're doing here, we're doing a different base. So normally if you do log, it's base 10, I believe. So here we're saying it's base E. So it's a natural log. And that'll give us a slightly different exponential distribution, but it's what we want for this. There's just a way you can adjust your distribution here if you need. So we're doing natural log instead of a log. But that should get us this method here. So now we just need to convert it to a time span. Service time equals new 0, 0. We'll just take the int portion of this. So if service time is less than yeah, I'm getting more information out here is all I'm doing. So put up here in the so here private time span shortest equals new. To say nothing goes longer than 100 hours for sure. Longest equals new. One second to long, shortest. So let's go back down here. So that's all we're doing here. Call it shorter. We're just getting us more statistics here. Service time, we'll do the same thing for longest. Now I think we're good. Back to where we were. Oh, we need to add the total. There we go. So add it to the total time. Now we have a duration. Registrant dot service duration equals duration. Registrant dot service time equals service time start. Dot departure time dot time equals service start time dot add duration. There we go. So add's a method that does exactly what you think it does. It takes the duration here as a time span, so how long something takes, and just adds it to whatever the start time. So there's some information. So once you're done, we can now calculate how long it takes you to finish and leave. So we can do the departure time it's going to be something like this. Departure. I'm doing time here. What's happening here is I'm just grabbing just the time, so that's getting off the day and month and year. It's just getting the time. Only reason I'm doing that's the only thing I actually care about. As far as actually needing to do that, probably don't need to do that. It's probably fine just to leave it as is. But that is what I'm doing, so I'm going to stick with it. But that's all that's happening there. Is I'm just cutting off the day portion of it. So we also need to add these events to the queue, though. Departure. So there's a schedule method. Where you go. Find up here. So this is back in handle arrivals. That's all. So we also need to handle departures. Here. Handle departures, and it has an event. Departure event. Count of departures plus equals or plus. This will be very similar. So int registrant ID equals departure events dot ID. There we go. Like that. Window index equals find window for registrant. This will be where we actually do the window information. So this is only used here. So we'll do return int find window for registrant int registrant ID for int I equals 0, I less than registration window dot count plus. So if windows at I dot count is greater than 0 and at I dot peak registrant ID equals registrant ID. So if the IDs match, then we'll return I. If we get all the way to the end, we'll throw a new invalid operation exception. Matching registrant not found in any queue. So in that case, they've left the queue and the simulation broke. Back up here. Now we've got the window. Registration windows at window index. Got the queue. And members at window index dot remove at position 0. Remove the first position. So what's happening there, as you can see with the Windows numbers, like I said, the registration numbers, like I said, I don't think I'm actually going to use them anywhere. I think they need to be removed, but what I was trying to do here is just count how many people are actually in a line, and to do that you should just be able to grab the line and say how many there. So I really don't think I've needed to do. We'll go ahead and keep it, but just a thought. Index count greater than 0. Equals I think the language server froze up. There, what am I doing there? That looks like I'm doing the same thing. That feels like a bug too. Yeah, so when they arrive, we add the registration. Arrival event. Know the part, we do the same thing. I'll leave that in. That feels like a bug though. I think I don't need to do this here. Again, we'll leave that in for now, but that feels suspicious. All right, back up here. Longest line. We'll do if q equals fine, or just count. Longest q, need to write the method. I said method, but property. Longest q. What we can do here, we can take advantage of the ability to actually do something with these. So do private int longest q index equals 0. It's a count, though it's not an index. Here, let's make this instead do this. Return longest q count. Here we'll say if value is greater than q count, then we set it. Like that. That's terrible spacing. There we go. So there's us a property that a non-auto property. So most of these are auto and they're handling this part of it behind the scenes. Here we're doing it ourselves, so we can do a little bit of logic here. I think that pretty much does the simulation part of it. I guess we need to do the find the longest count. it is I do it twice, but I feel like that's suspicious that I do it twice, so probably going to change it. But now, private int find largest line count. I want to say the longest. Or int I equals 0, I less than number of windows, I plus plus. If windows at I dot count is greater than longest line. So this is just doing the opposite of the shortest line. Let's rename this. There we go. We'll rename it to that. Back up here to where it's used. And we are right at out of time. We'll do one more. We'll say to do start back from here. We'll start back from here. We'll go ahead and slow the simulation though. So to do that, the reason you're going to do this is otherwise it's going to run really quickly. So by slowing it, we're going to be giving ourselves a little bit of time to see the actual simulation as it runs. We're not going to give it a ton of time though, so we could adjust this here though, but we'll say 100. So that's 100 milliseconds. So thread sleep, it just stops whatever's executing, just stays there. Spins the current thread. So whatever's happening, it just freezes for, in this case, 100 milliseconds, which is quickly. Should make that a constant. We'll say private const int milliseconds to delay display. We'll put that in there. Find it again. There we go. All right. So next time we'll pick up there with display. And we're almost through we've at least almost got a simulation. There's a couple to dos and some bugs, but we've almost got it. The one thing you may be thinking and noticing is I'm using a lot of these returns and a lot of these are void. That's because there's a design issue here. So this is just been designed so that it'll work. Not a lot of effort's been put in to make it actually object oriented. We're going to see when we go to try to actually test it that that's actually a problem. And that's a problem we can solve through object oriented code. So maybe it's not the best way, but it's the example I'm using to show this. So that'll be the thoughts of where I'm going. So we'll get this working and then we'll start refactoring. Start testing and refactoring. But till then, we'll keep building it up because we are very close to done now. So next time we may take that last step. We may do the display method. Where it's at. The next time we may do display, and then we'll start doing some we'll test it and see if it actually works, and then we might try to clean up some of the to-dos. That's going to do it for episode 31. So thanks for sticking around. we'll call it there. So thanks for watching and have a wonderful day.